problem we're about to graph is r squared is equal to 4 cosine 2 theta. One of the things that we didn't emphasize as much as maybe we should last week is arguably one of the most important things you need to be able to do when graphing this is to understand the symmetry of the shape. So testing for symmetry is key to being successful in graphing polar equations. So we'll spend most of our time talking about that. So again, we want to graph r squared is equal to 4 cosine 2 theta. What I did was I have a lot of information down here that will assist me in checking the symmetry of this shape. So let's start that. So we got r squared is 4 cosine 2 theta. And what we're going to do is we're going to substitute in negative r, negative theta, into this original equation. If we end up with the same initial equation, that will be confirmation that this equation is symmetric about theta is equal to pi over 2. All right, so let's substitute that. Negative r squared is equal to 4 cosine of 2 times negative theta. Again, we're substituting in negative r, negative theta. One of the things that's important for students who are studying this to understand ahead of time is that the cosine of negative theta is equal to the same as the cosine of theta. That's an identity that they would need to be aware of. Also, the sine of negative theta, they would have to be aware that the sine of negative theta is negative sine theta. That would be something that students would have to know ahead of time. So let's continue on with checking for identity across theta is equal to pi over 2. You get r squared is equal to 4 cosine. The cosine of 2 times negative theta is the same thing as cosine of 2 theta. So notice how we substituted in negative r, negative theta, and you ended up with the same initial equation. What that tells you is that this graph is symmetric about theta is equal to pi over 2. All right, so that's going to assist us in the graphing of this equation. So one of the things that you need to know with polar equations is oftentimes the graph is symmetric in more than one way. So what we're going to consistently do with each of the graphs we have an opportunity of graphing today, we're going to check for symmetry across theta is equal to pi over 2. We're going to also check for symmetry across the polar axis. When we're working with rectangular coordinates, the polar axis we call the x-axis. So let's check for symmetry across the polar axis. So we got r squared is equal to 4 cosine 2 theta. Let's substitute in r negative theta. We'll substitute in r negative theta. So we get r squared is equal to 4 cosine 2 times negative theta. Again, the cosine of negative 2 theta, that's the same thing as cosine 2 theta. Notice again, we substituted in negative theta and r. We ended up with the same equation. What that tells you is this is symmetric about not only theta is equal to pi over 2, but also the polar axis or the x-axis if we're working with rectangular coordinates. Let's check one more type of symmetry across the pole by substituting in negative r theta. All right, so we have r squared is equal to 4 cosine 2 theta. All right, so we end up with negative r, that's squared, is equal to 4 cosine 2 theta. We end up with r squared is equal to 4 cosine 2 theta. And it turns out you end up again with the same exact equation, which tells us that this equation is symmetric in all of the 3 ways which we'll be testing for these types of equations. So that's going to assist us. In graphing this equation. All right. Another thing that's going to help us is to, let's just begin the graphing process. There are other things that could help us graph this, but I don't want to go into that right now. All right, so let's start with 0. The angle 0, let's substitute that into r squared is equal to 4 cosine 2 times 0. We end up with 4 cosine 2 times 0 is 0. You end up with a cosine of 0, which is 1. You end up with 4 times 1, which is 4. You get r squared is 4, and you take the square root, you're going to get r is equal to 2. All right, so you're going to plot the point 0, the angle 0, and you go out to 2. Don't forget about the symmetry of this shape. This is symmetric about. This is symmetric about theta is equal to pi over 2, so you can put a point over here as well. All right, so let's continue to plot point after point after point until we get a good feel on what we're working with here. All right, so now let's substitute in pi over 12, or 15 degrees. 15 degrees. Substitute in that into r squared is equal to 4 cosine of 2 theta. R squared is equal to 4 cosine of 2 times a pi over 12. You end up with 4 cosine of pi over 6. Cosine of pi over 6. You get cosine of pi over 6. That's the cosine of 60. You need a special triangle for that. Put a 60 here, 30 here. Get 1 radical 3, 2. All right, so the cosine of 30, that is radical 3 over 2. This simplifies to 2 radical 3. I think what we'll do is you just put that in the calculator. Put that in the calculator. You're left with r squared is equal to, let's put that in the calculator. You end up with 4 times radical 3, you divide by 2, and you get 3.5 roughly. You're going to end up taking the square root of that, and you get 1.9. All right, so you get r is equal to 1.9. So you're going to plot that. You get the angle pi over 12. You get 1.9, which would be about right there. This is symmetric. This graph is symmetric about the polar axis, so you can put a point here. This graph is also symmetric about theta is equal to pi over 2, so you can put a point right here. And the graph is symmetric about the pole, so you can put a point right there. Hopefully you see already the advantages of checking for symmetry. We got one coordinate, but it allowed us to plot 3 additional points. So that's a good deal for us. Now let's substitute in pi over 6. Substitute in pi over 6 into r squared is equal to 4 cosine of 2 theta. We get 4 cosine of 2 times pi over 6. You get 4 cosine, 2 and 6 cancel, pi over 3. Pi over 3, it's the same thing as 60. The cosine of 60 is half. You get r squared is equal to 4 times half. You get r, 4 times half is 2. You take the square root of 2, you're going to get r is equal to radical 2, which is about 1.4. You plot the point, pi over 6, 1.4, which would be about right here or so. It's symmetric about, this is symmetric about the polar axis, so you could put a point here. It's also symmetric about theta is equal to pi over 2, so you can put a point about right here, about 1 point, radius of 1.4. Not only that, it's symmetric about the pole. So you could reflect this across the pole, and you get a point, about right here or so. The radius is about 1.4. All right? So you can see the shape beginning to take effect. Let's plot another point. Let's plot pi over, let's substitute in pi over 4 into r squared is equal to 4 cosine 2 times pi over 4. you get r squared is 4 cosine pi over 2. Cosine pi over 2. Cosine pi over 2, that's just 0. So you get r squared, that's just going to be 0. All right, so that won't help you very much. You get a point at the origin. So let's go on and graph this right now. We want to get through as many problems as we can. The shape of this is called a lemniscate. All right, you get a shape that looks something like this. All right, something like this, sort of a bow tie looking shape, something like this. All right, very good. All right, so something like this, called a lemniscate. All right, like a bow tie like shape that we want you to be familiar with. Something like that, okay? So that's our first polar equation that we're graphing. I like the way we went about this problem because we checked for symmetry first and then we graphed. A lot of videos that I've examined and studied, they only do the graphing. They don't go through the symmetry. So hopefully this is a presentation that a lot of people will get some benefit from.